Stay focused, stay curious, and let's dive into another powerful lesson.
Now, let's move further. The next thing we want to look at is the equation of a straight line. The equation of a straight line. The equation of a straight line can be represented in several forms. In the earlier part of this video, I showed you two equations of a straight line. Now we have about 4 different types of it. The most basic form is the point slope form, where you have your arbitrary points x1, y1. So this is a point slope form where you have your y minus y1. We're going to be using this a lot, and you expect it to be more conversant with this. In fact, all of them. So when you talk about the slope intercept form, y equals mc, mx plus c, that's when there's an intercept. We also have where the line crosses the origin. Now in this case, there is no intercept, right? Intercept is 0, which is y equals mx plus 0, which is y equals mx. So in that case, we present the equation of a straight line to be y equals mx. Now, one major thing about a straight line is it is a linear equation and also an equation of first degree. When you see a square on an equation, you know that that equation cannot be a straight line, right? Now you have a general form. The general form of a straight line is represented to be ax plus by plus c equals 0, where a, b, c are constant, right? So you have these 4 major forms of representing equation of a straight line, and I say the most one we'll be using the most is the point slope form. So do well to write that down on your notebook. Now let's continue. We have some examples here to fully understand how to find the equation of a straight line. Now, the first example here we have is to find the equation of a line with gradient 2 and passing through the point minus 1, 3. Now let's go back and look at our point slope formula. You have y minus y1, which is your point. Your y1 here is where you use in forming the equation. Your y1 here is your point, and your m here represents your gradient. Your x1 here is your point. Your x and y are constant, they don't change, right? So you're only giving value of x1 and y1 to substitute, and then you can be able to find the equation of the slope, or the equation of a straight line rather. Now we are taught to find the equation of a line with gradient 2 and passing through the point minus 1, 3. So here we are doing a very simple and direct substitution here. Your m is 2, your x1 and y1 respectively are minus 1, 3. So substituting your values, y minus 3 equals 2 into bracket x. Remember your x1 is minus 1, so you want to put that in the bracket. 2 into x minus 1, giving you 2 into x plus 1. Solving your equation, you have y minus 3 to be equal to 2x plus 2. Collecting like terms, you have y to be 2x. Remember, bringing your negative 3 this way, it becomes positive 3. So you have y equals 2x plus 5. Now, what kind of way are you presenting this? Your final answer, you discover that you're presenting it in the slope intercept form, right? Where in this case, your slope here is 2. Can you see it? Y equals mx plus 5. Where c here is your intercept. So in this case, you can use it to always get your equation of gradients. You can see mx plus c. Your m here is representing 2, your x, and your c, 5. So in case you just ask, okay, what's the intercept, you can quickly get it from the equation given to you. Let's look at the second equation. Find the equation of a line with slope 3 and intercept 2. In this case, you're just simply substituting it in the slope intercept formula. So you have to know all this formula, right? I gave you the 4 of them: the slope intercept form, the point slope, the general form, and where you have that from the origin.